Hey friends, how's it going? Now we're talking about the chip industry again. A few days ago we mentioned in a video that the leading advantage might only be CUDA. Actually, I was really impressed by how strong the CUDA moat is. So why does CUDA become a moat? What efforts has been made to cultivate the market? And what has been done to dominate the market? Finally, we'll also share our views on comparing nVidia to Cisco. Now let's start from the origin of CUDA. As you know, nVidia is the first company to propose the term GPU, and it has been researching GPU for a long time. Back in 2001, nVidia implemented an instruction set for Vertex engines, and it presented the program model on GeForce 3, which can be considered a step towards general-purpose programmable shaders. However, the progress was really slow. In 2005, GeForce 7800 was released, which still used the dedicated Vertex and Pixel processors. Then in November 2005, Microsoft's Xbox 360 was launched with a TI Exynos chip, which adopted a unified shader architecture. This means that there were no longer dedicated Vertex processing units, or dedicated Pixel processing units anymore. Instead, a type of general-purpose processing unit was introduced. For some reason, nVidia didn't accept this design and instead overpriced at the time, so Microsoft ended up giving the contract to ADI. By the way, Exynos was the world's first GPU to adopt a unified shader architecture. In the traditional GPU, Vertex shaders and Pixel shaders were independent and specialized, with a fixed number of each. However, in different application scenarios or game scenes, the required number of units varied and sometimes changed rapidly. Therefore, it's common to frequently encounter situations, as depicted in the diagram, where one is extremely busy while the other is extremely idle. The unified shader architecture combined these two types of shaders into a resource pool, allowing for dynamic allocation of resources to handle different tasks. Obviously, as can be seen, resources can be allocated according to the needs of the scene to handle different tasks on the fly. Of course, the prerequisite is that there are sufficient resources available. So, how do they be able to process different tasks? That's where programming comes in. This has greatly improved the programmability of GPU, hasn't it? Bah! It seems that nVidia was inspired by this and suddenly realized the future of GPU. Eureka! With that, the progress has been rapid and remarkable. The next year, nVidia released the Tesla Architecture's G80 GPU, which was their first unified shader model. Also, this GPU introduced scalar stream processors, single instruction multiple thread model, and shared memory between threads. To explain briefly, a scalar streaming processor can only handle one-dimensional calculation, but with the help of the single instruction multiple thread model in the shared memory, GPU can process a large amount of data concurrently with just one instruction. As a result, there's a significant boost in both performance and efficiency. More importantly, the Tesla architecture was the foundation of CUDA. From then on, the developers could easily use GPU's powerful parallel computing capabilities. Andrew Wang, a big shot in AI, once said, before the advent of CUDA, there were probably fewer than 100 persons in the world who could program on GPU. With CUDA, it became a very easy thing to do that. I believe that only with the experience of time travel, the famous science fiction event, could Jensen Huang possibly have known how powerful the CUDA would become in the future. He knew that CUDA could accelerate scientific computing, which was definitely useful for the scientists and the researchers. So nVidia initially promoted CUDA in universities, which meant cultivating user habits by burning money. Look, isn't that very much in line with the way of thinking of internet companies? In 2008, the world's first CUDA Center of Excellence was established at the UIUC, donating $500K into GPU cluster with about $800K. Oh my godness, what a great deal. Soon after, prestigious schools of science and engineering from all quarters started to apply for CUDA centers. In 2010, nVidia launched the CUDA Research Center and Training Center, provide training courses to teach people how to program with CUDA. Moreover, they even offered discounts to academic researchers to purchase GPU. To this day, nVidia continues to engage in educational discounts. You reap what you sow. More and more research labs started using CUDA in their research. Imperceptibly, the CUDA ecosystem was nurtured. Let's talk about nVidia's financial report in 2011. It mentioned that the number of attendees at the GTC increased by 50 compared to the previous year, and the number of submitted papers increased by 5-fold. You see how fast it grew. We all know that CUDA is an ecosystem that combines software and hardware, and it's entirely new. Starting from 2007, all of nVidia's products were like being forced to join the CUDA ecosystem. This would bring significant overhead in R&D. If you look through the financial reports, you can find some clues. From 2009, R&D expense began to surge, and by 2014 it accounted for 32% of the annual revenue. To be honest, we can't exactly figure out how much of this was directly invested in CUDA, but as a high-tech company, heavy R&D investment is natural. After all, talent and innovation are the keys to success. R&D investment ratio of nVidia is indeed impressive. Let's take a look at other major companies. Apple's R&D expense ratio is less than 10, Amazon's is around 10-15, and Microsoft's is around 15-20. Even within the semiconductor industry, AMD's R&D investment ratio is less than 15, and Intel's is around 20. So nVidia's investment is quite large. But this also shows their emphasis on the CUDA ecosystem and their investment in future technology development. This is a big bet, and it seems they've won. Let's take a look at Intel and AMD, old rivals of nVidia. As we mentioned earlier, ATI developed the Xenos GPU for Microsoft's Xbox 360 in 2005, and then it launched the Radeon HD 2000 series of its own unified rendering architecture in 2007. At that time, ATI was not inferior to nVidia in terms of GPU technology, but in 2006, ATI was acquired by AMD. In those days when CPUs were paramount, the acquisition was mainly aimed to integrate GPU and CPU in order to boost AMD's CPU sales. But who would have known that this acquisition led AMD into a decline decade? To survive, AMD had to sell off its assets, and didn't have the resources to invest in those purely capital-intensive projects. It wasn't until 2016 that AMD finally regained its strength and launched its ROCM platform. As for Intel, we all know that they're making incremental improvements to their products at a leisurely pace with tick-tock model. It's just like squeezing the last bit of toothpaste out of the tube. There's a saying that goes, the first step ahead, and you'll be ahead for 1,000 miles. This seems to apply to NVIDIA's lead in the CUDA ecosystem. NVIDIA has been investing in CUDA ecosystem for over 10 years, and this investment has created a strong moat. It's like sharpening a sword for 10 years, and NVIDIA's sword is now extremely sharp. Imagine you're a college student, and it happens your professor knows CUDA well. The parallel computing textbooks are based on CUDA, and even your lab mates uses CUDA for research. When you graduate and look for a job, you'll find that all the job descriptions require CUDA skills. You still want to spend a lot of time studying ROCM on your own? I'd say, bro, you must fall in love with AMD. Frankly speaking, studying ROCM won't make you write papers any faster, nor will it make you develop models more efficiently, and it won't make you solve problems more quickly. On the contrary, if you run into any weird issues, you might not even find someone to ask. You'd have to spend half a day researching, debugging alone, and wondering, is it an issue with the data, the code, or is it a problem inherent to the platform itself? From another perspective, suppose you're a boss, you'll most likely choose CUDA as well, unless you have particularly unusual requirements. Why is that? It is because the CUDA community is so great that solving problems is relatively easy. It's also simple to recruit talent, both in terms of social and campus recruitment. It's much more straightforward. This is NVIDIA's moat, and it's not just an ordinary moat. It's the wide and deep river in the poem of the ancient Chinese poet Wang Wei. This is why CUDA can still dominate the market with its mature ecosystem and broad application foundation, despite the intense competition. It's like, no matter how hard the challengers try, CUDA remains stable, unruffled, and peaceful. Let's talk about something else. You might not believe it, but even today, the official hardware support list for our ROCM only includes those enterprise-level or high-end graphics cards. In reality, many low-end cards have been tested to support ROCM, but the support level is unknown and you have to find it out by being a guinea pig yourself. We've all heard the fable of the tortoise and the hare. The tortoise can only win if the hare takes a nap and sleeps, but in this race, the situation is more complicated. Let's not rush to label who is the tortoise and who is the hare. Just consider this. If the hair can outperform you and invest money even more fiercely than you do, can you handle that? Recently, I've heard some people comparing nVidia and Cisco. Personally, I think this comparison is, well, a bit inappropriate. Let's talk about their commonalities first. I mean what they had in common during their respective golden ages. Both companies are technology leaders, setting the trend. They both provide infrastructure, like water cellars, offering necessary resources and services. Finally, they are both dominant players with a market share of over 80% in their respective markets. However, there's a but. Cisco has a bunch of proprietary protocols, but we have to admit that the internet is built on open protocols. Other manufacturers can easily achieve interconnectivity by adopting to these open standards. As for private protocols, they're mostly used for optimization and adding extra features. Of course, there are cases where proprietary protocols are used to hinder competitors. As for nVidia, it's not just a hardware company with strong hardware R&D capabilities. Its CUDA is not just a piece of software. It has built an ecosystem, a moat. Let's make an analogy. Network protocols are like languages we use in daily communication. No matter you speak Chinese, English, or Japanese, as long as there's a translator, everyone can understand each other. The CUDA is like the underlying social mechanism, building a system that allows all kinds of people to live and thrive. ROCM and One API are like other systems. But if you want to live simply and comfortably, you'd still choose CUDA. Let's take a look at Microsoft, which is its own DirectML. But as a software giant, it's so little enthusiasm for challenging the CUDA ecosystem. So DirectML is more like a defensive strategy. As for Intel and AMD, both companies have ambitious goals to kick nVidia's ass. But they're not software companies, or rather, software is not their key business. They are more focused on defining and exposing device interface with standard communication protocols to ensure that devices can connect and interact correctly and the drivers run stably. Software companies, on the other hand, focus on building a community around software developers, SDK developing tools, supports, and even application stores. The goal is to attract more developers and end users. In this way, nVidia has transitioned from a hardware manufacturer, initially just a player within Microsoft DirectX ecosystem, to gradually cultivating its own ecosystem that combines both hardware and software. To keep its CUDA dominance, nVidia updated its end-user license agreement in CUDA 11.4.2, released in September 2021, which explicitly prohibits users from reverse engineering or decoupling or disassembling any part of the SDK output, especially not to try running it on non-NVIDIA platforms. This is quite normal, right? As most companies would have such agreements to prevent competitors from engaging in simulation or emulation. There's an open source project called CUDA, which aims to make CUDA applications run on AMD GPU without modification. Note that this project was created on GitHub in 2020. Here's the fun part. Michael from Foronics.com did a performance test using 3ECG software Blender, and found that using CUDA as the backend and run it through CUDA resulted in faster than using native ROCM HIP backend. So I guess it's because Blender has more extensive optimizations for CUDA than for ROCM, which led to this result. Let's talk about nVidia's recent events. Last month, nVidia launched NIM, nVidia Inference Microservices at GTC. I'm going to take a wild guess. This might be nVidia's preparation for the future. When the GPU market becomes less prosperous, they can still provide the microservices, put the GPU capabilities into pieces, and sell them to small and medium-sized customers. This logic looks like the approach Amazon took when it launched AWS cloud services. Right? If it works, nVidia will achieve one more moat. Even in the worst-case scenario, it would make the current CUDA moat even stronger. TensorFlow and pytorch, the two popular frameworks, they both have large communities. Although they support multiple backends, developers or engineers still tend to choose the CUDA backend more often. OpenAI's Triton seems to take place of CUDA, but it's essentially a front-end sibling of CUDA, since it finally outputs PDX code. Therefore, all of the above can be categorized as part of the CUDA upper layer ecosystem. In conclusion, I don't think it's a good idea to compare nVidia to Cisco, but if we compare nVidia to Apple, it may be appropriate. Both of them have tightly integrated software and hardware, and building powerful ecosystems. Wanting to challenge such an ecosystem, The best time is when they're still infant, or waiting for the something new emerge to disrupt the existing ecosystem. Time flies, and that's a wrap for today's video. Hope you guys enjoyed it. If you think our videos are pretty cool, please hit that subscribe button. We'll catch you in the next video. Thanks for watching.